Last time we made the internal mechanism of the ATC for the CNC lathe, but there were some little issues related to the unexperienced engineer designing this stuff. But it's gonna be okay. Let's start off with cold bluing the parts to make these more resistant. Fir loop. Looping is required after the cold blue oxidation. After some rage in the workshop last time, I fixed it a bit this part, which holds the screws with adding countersinks. All the springs should have about 250 kilograms of force. That's about 550 pounds, translating for my imperial friends. I added 3 holes to make possible the assembly. The force is there when the springs are compressed. Now the snap ring. And the split color, so the snap ring doesn't get destroyed right away. It seems it has some sense now. Now the ball between the air cylinder rod and the shaft. So the shaft doesn't rotate the air cylinder when it will rotate in the future. The screw is going to be screwed into the air cylinder rod. The ball is going to sit right here. Let's test it after compressing the springs. It seems the air cylinder is strong enough. Now the oxidation layer, in order to avoid painting it, which would go off anyway. Alright, let's get back to the fun part. I've got the steel plate, aka round bar, 180 mm diameter, 50 mm thickness, C45 steel. I'm going to start it off with facing the top surface using my favorite high-speed steel end mill. Now the surface is flat. Let's mill out all the excess material from this side. Using ZW3D, I designed the toolhead some time ago. Now I prepare the CNC machining toolpaths using the CAM module. First, milling the top pocket for the shaft flange. Then the mounting holes for the hearth coupling. And finally, taking off some material off each side to have less problems in later setups on the mill. Quick simulation to make sure everything is okay. First, I digged in with one of my end mills in the center. And the next operations will be done by the CNC controller and I'll go away. Everyone knows, CNC mills do the work without any human being. Everything is being done by itself. Now the drilling operation. Make sure everything is perfect. The boring tool. Moment of truth? Seems about right. Now, the sidewall's contour. I think we can visit the lathe now. It already looks interesting, at least. I love the butt surface finish on it. Looks lovely. Let's machine the external surface. Maybe not mirror finish, more like brushed finish. Let's proceed with facing the front face. I'm definitely fine with it now. Back to the mill. Quick center hole. And now it's about to get some real shape. I'm going to mill out the sidewall excess material. It took some setup time, but we are ready to machine. And 7 more times the same. I borrowed the 3-jaw chuck from my old lathe, and now things are getting scary. It would be a shame to destroy this part if something goes wrong. I've got to machine each tool pocket. That's a lot of material to remove, and many chances to do mistakes. Using the W3D, I prepared the tool paths, roughing first and then the steep surface finishing, both with the same end mill. Dialing in, and we are ready to go. C45 is lovely to machine, especially if you have a nice and sharp tool. roughing done, now the finishing passes. Looks similar to what I saw on the PC display. Let's check with the tool shank. I ordered also recently this little collet. Just to try it out, might be helpful one day. Next step, next holes. But let's adjust the focus first. With a bigger end mill, I made a counterbore for the axial screw. This part would like to have some of its holes tapped. I use a manual drilling machine to do the tapping to keep the axis perpendicular to the top surface. Back to the mill, setup number 67. Chamfers won't hurt. Actually, edges won't hurt anymore too. Back to threading. I would like to put on an oxidation layer on it too, but it requires a quick cleanup before. And some fear loop on top of it. Quick dry wiping and it's finished. Would you believe it? On the first attempt, honestly, it was like over a month or two of work, considering only weekends, of course. Hopefully, this will be the last assembly process of this whole ATC turret. Squeaky. I'm going to put some oil on it. Now the upgraded spring mechanism. Not to forget the snap ring. And the snap ring supporting collar. Actually, nothing new to say. You saw it already in the beginning of the video. There is also the stepper motor flange to be done. And this is a steel plate, 12 mm thick. I'm going to make it on the Carvera Air. I was recently really curious if it will work with steel. These are the toolpaths generated by the Carvera cam. Let's see how it does. I'm going to take light cuts. It has a casted frame, but it's a small machine anyway. Being honest, it seems it can slowly mill steel, but it gets a bit worse as the end mill gets hot and loses its sharpness. Anyway, it's kind of impressive to see it actually cuts steel. These tiny machines get quite cute recently. I milled some of the features with the Carvera, but I'm going to finish it on my old-fashioned machines. The Carvera seems to get the job done, but I think the easier features can be done faster on conventional machines though. Those seem to have a bigger material remove rate, which is related mostly to the size of the machines. Threading number 1,073. Now the side holes to mount it to the ATC frame. And the flange is finished. I added also a simple belt tensioner to keep the belt tight. And I guess we are almost there. There is also the top cover. Actually, it was made a few videos ago. I had to make a little spacer, due to some little mismeasurements, let's say. I decided to quickly make a nameplate for it today too. There will be no time for such things next time. Next time I expect a lot of action, and there will be no place for nameplates. This time I'll give a go with aluminum. I think this tiny Carvera Air likes aluminum more than steel. This part seems to agree with me. Let's make some place for the new toolhead on the machine. Next time we are going to test it on the battlefield. But in order to do that, we've got to make the tool holding wedges first. Thanks for watching.